What is unfolding beneath Naples right now was never meant to be possible. In recent weeks, residents inside the Campi Flegrei caldera have begun noticing something deeply unsettling. Floors warming from below asphalt, radiating heat walls sweating as plaster begins to blister. Places that should feel like cold stone now behave as if an unseen oven has switched on beneath the city. Thermal scans confirm it. Several of these hotspots are warm enough to deform everyday materials. This is not normal, and scientists say the sudden spread of ground heat is the most alarming signal Campi Flegrei has shown in modern history. But what changed beneath Naples, and why now? Across Pozzuoli and the Solfatara region, eyewitnesses started reporting the same chilling detail: their homes were warming from the inside out. Not from heaters, not from the weather, but from the ground itself. Some describe ceramic tiles softening. Others say their basements feel like industrial furnaces. Parents are moving their children's bedrooms into cooler hallways. Independent thermal cameras show strips of pavement glowing on heat maps as though invisible fires are burning beneath the surface. Authorities tried to calm residents, blaming bradycism, the natural rising and sinking cycle Campi Flegrei is known for. But this is no longer bradycism. The heat is too strong, the spread too fast, and the pattern entirely new. So what is forcing this heat upward? To understand what is happening, you first need to know what lies beneath Naples. Campi Flegrei is not a single volcano like Vesuvius. It is a vast 15-kilometer-wide volcanic system, a submerged bowl created by two prehistoric eruptions so violent they reshaped southern Italy. The first, about 39,000 years ago, covered much of Europe in ash. The second, around 15,000 years ago, left behind the enormous depression that nearly 3 million people now call home. For centuries, this system has simmered rather than slept, slowly collecting heat gas and pressure. And over the last 2 decades, that simmer has intensified. But in the past year, something has shifted dramatically. Satellite radar shows Campi Flegrei has been rising slowly since 2005. Recently, that uplift has tripled. Entire blocks of Pozzuoli now sit noticeably higher than before. Old docks that once touched the sea now stand above the waterline like relics from another age. And each rise brings something else with it. Earthquakes. More than 50,000 small quakes in recent years. Each one a fracture opening microscopic pathways through the crust. Scientists call them chimneys cracks that let heat and gas escape. And every new chimney thins the lid that keeps the magma system contained. That thinning may be the most dangerous development of all, because once that barrier weakens, pressure begins to find its way out. Over the last month, gas emissions across the caldera have changed in both strength and chemistry. Vents that were once warm now erupt with scalding steam. Sensors detect hydrochloric acid, carbon dioxide, and hydrogen sulfide drifting directly into neighborhoods. Metal handrails corrode overnight. Pets fall ill from the fumes. People wake with burning eyes and irritated lungs. Then came the discovery that changed everything. Passive infrared scanners, normally used to detect insulation leaks in buildings, now reveal glowing patches on sidewalks, courtyards, and driveways. Heat is not just rising through volcanic vents. It is rising through the city itself, and that should never happen. Heat at the surface means something deeper has shifted. Beneath any volcano, magma is kept in check by solid rock above it, a thick barrier trapping pressure. But when that barrier cracks, gases trapped inside the magma begin to escape. As they rise, the remaining magma becomes lighter, more buoyant, accelerating upward. It is the classic pattern before an eruption. Scientists compare what they see now to the 1538 eruption that created Monte Nuovo, when weeks of quakes were followed by sudden ground heating, violent steam blasts, and the birth of a volcanic cone in just 7 days. But Monte Nuovo was tiny compared to what Campi Flegrei is capable of. And this time, the system appears larger, hotter, and far more pressurized beneath a modern city. So what happens if the lid fails today? If Campi Flegrei ruptures, the earliest signs would likely be phreatomagmatic explosions. When groundwater meets rising heat and flashes into superheated steam, the effect is violent. The crust shatters. A column of ash punches into the sky. Shockwaves ripple through the city. Then come the pyroclastic surges, fast-moving clouds of gas, ash, and debris hotter than 400 degrees Celsius. They travel at hurricane speeds, flattening buildings and engulfing anything in their path within seconds. Beyond the immediate blast zone, ashfall could reach the airport, major highways, and even parts of Europe, depending on wind direction. And Naples, built like a natural amphitheater, would funnel and echo the shockwaves between its ridges. The destruction would not only be physical, it would cripple transportation power and communication almost instantly. But the greatest danger is not the eruption itself. It is what happens in the minutes before it. The Italian Civil Protection Agency has already raised alert levels twice this year. Maps show red and yellow zones, marking tens of thousands of people who might have only minutes to evacuate. Schools practice drills, hospitals rehearse patient transfers, buses wait for emergency mobilization. But Naples is an ancient city. Many streets are narrow and easily blocked. There are few outbound highways, and if an eruption begins, ash clouds or lava fountains could cut off escape routes at the very moment they are needed most. Even with perfect planning, evacuation would be chaotic. And then scientists looked deeper, literally. Teams using muon tomography, a technique that tracks cosmic particles passing through rock, identified low-density zones only a few hundred meters below the surface. These pockets suggest rising magma or gas-filled cavities. Another team measuring electrical resistivity found fresh pathways funneling heat and vapor directly beneath solfatara. Every method, seismic, chemical, thermal, and imaging, points to the same conclusion: Campi Flegrei is critically pressurized and its crust is losing integrity. While scientists debate the exact thresholds, residents do not need instruments to know something is wrong. They feel it in their homes. Bread rises too quickly in warm kitchens. Tap water emerges warm even without a heater. Soccer fields feel soft underfoot, almost spongy, as if the ground itself is breathing. Some older residents say the quakes sound different now, deeper, more resonant, like a giant creature shifting beneath the earth. A fisherman in Pozzuoli keeps a suitcase permanently packed by the door. Real estate values in high-risk zones have collapsed. Insurance companies refuse new policies. Cafes grow quieter as conversations drift toward evacuation routes, shelters, and which belongings people would save. Everyday life continues, but under a widening shadow. The next scenario scientists fear is even more complex. Campi Flegrei might not erupt from a single location. Because the crust is cracking in multiple areas simultaneously, some models show several vents opening at once. Imagine ash plumes rising from different streets or lava fountains cutting across separate neighborhoods. Highways could be severed, rail lines blocked, and evacuation corridors isolated within minutes. In this scenario, emergency planners do not face one eruption. They face several, each unpredictable, each capable of trapping entire districts. This is the nightmare situation the one emergency teams train for, but hope never arrives. So how close is the system to failure? Pressure underground continues to rise. Surface heat is spreading, gas emissions are intensifying, and the crust is fracturing faster than before. Geology has a simple rule: pressure always finds a release. Either Campi Flegrei stalls and cools, a scenario scientists say is becoming less likely, or it breaks through. And with every warm basement, every glowing sidewalk, every sulfurous breath escaping from a new fracture, that breakthrough edges closer. For the millions living above this restless giant, the question is no longer if, but when. And the most dangerous signal, the one scientists fear most, has not happened yet.